Ugh! What on earth is that smell? Ew! It's that synthetic banana scent, isn't it? Holy crap, that stuff's disgusting! But actually, in case you didn't know, lots of artificial fragrances are made using ester groups, which means they're what are behind a lot of these distinctive aromas. But just what are ester groups? And even more importantly, how are they made? Well, stay right here because that's what we're going to be showing you today. So, esters. What are esters? By definition, an organic ester is what you get when you take a carboxylic acid and swap out the OH group for an alkoxide. And that little bit of info is really good to know when trying to understand what's called esterification, the process by which esters are made. Esterification always seems to follow the same pattern. An acid and an alcohol yield an ester and water. You're gonna want to remember that. If you want to know more about the properties of esters and other kinds of organic compounds, we've got a great video on all that right here. Okay, so an acid and an alcohol can be turned into an ester and water. You want to know if we have an example in mind, don't you? Well, you're in luck, because we're about to show you how this process works. Let's go ahead and start with our reactants. The two we're going to be combining here are acetic acid, the kind of acid found in vinegar, and ethanol, also known as drinking alcohol. So two classic examples of their respective groups. Now the first in esterification is the protonation of the double bonded oxygen in the acetic acid. And where do we get that proton from? Well, the solution contains acetic acid, right? And as the name suggests, it's gonna behave like an acid. Meaning, some of our acid molecules undergo deprotonation, while others participate in the reaction. That is, the O gets protonated. This gives the carboxylic acid a positive charge, which gets distributed across the rest of the molecule due to the effect of resonance. So that means the carbon atom also gets a positive charge. Then we add our alcohol to this, and the hydrogen atom splits off the alcohol, causing the positive charge to disappear. And now what we have is a tetrahedral transition state. Now in the final step, one of the alcohol groups in our transition state gets protonated. This group becomes a kind of bonded water, making it a great leaving group. And now we have room for the electron density on the carbon atom again. One of the electron pairs on the hydrogen in the other hydroxyl groups folds down and the H splits off. And now we have our products, water and ethyl acetate. Alright, so now you know how the reaction for making ester works, aka esterification. The reverse reaction is called saponification, as in soap. We'll tell you why in this video right here. So, what are some questions you might want to ask about reactions like this? Are there other esterification reactions? You know it. There's the esterification of sulfuric acid, phosphoric acid, and silica, for example. So you can see how important this reaction is, because it's so universal for producing all kinds of esters. Okay, so what can we do with all these esters? As we mentioned at the beginning, esters are often used to make artificial fragrances and flavors. But their most important application is probably the production of polyesters, which are used to make clothes, plastic bottles, and other synthetic materials. So as you can see, esters play a super important role in our day-to-day lives. To sum up, esters are one of those classes of organic compounds without which the day-to-day lives we're used to would be pretty much unimaginable. What you need to remember is that esters are always produced the same way. An alcohol and an acid react to form an ester and water. Well, that's it for esterification. If you want to know more about the reactions for producing different classes of compounds, just keep clicking through the playlist. Have fun!